G'day and welcome back to the North Bourne Repair Cafe YouTube channel. This week we've got a short video looking at the repair or diagnosis and repair of a hammer drill. This is something I literally found off the side of the road. It was in very good looking external condition but did not work, and I'll talk you through my diagnosis and hopefully the repair. I hope it's useful for you. So here is the drill that I found. As I mentioned, found on the side of the road, and it's partially disassembled, but you'll get an idea of the condition. It looks really good. Often if it's been a tradies drill, you see they're very, very badly banged up and bounced around in the back of the truck. But in this case, you can see there's hardly a mark on the device itself. You can see the model number there, GBH 2SE Bosch. So my understanding, it's not a bad quality drill. Some more specifications, hopefully you can read those, zoom in and read those. Let's see if the camera will read those. Probably a bit blurry, but anyway. You can get the specifications from the model number. And so the interesting thing was the plug that came with it was the UK plug. So I'm not quite sure whether it's ever worked in Australia, but if you look at the voltage requirements, 220, 230, it should work fine here in Australia. It's not one of the 110 volt units from the States, and I've just put an adapter on here to match the Australian plug, just to see if I can get it working. Now, initially what was happening was this would blow the fuse. There's actually a fuse in the back of this particular plug, which is common in the UK plugs, I believe, and that blew as soon as I put the unit into the outlet and pressed the button. It blew the fuse straight away, which is interesting. So it's obviously a short in the system. So could have been the motor itself, or it could be the switch. So I did a little bit of searching online, and as it turns out, it's quite common for the switch unit here, which normally has a capacitor sitting on the top of it. I'll give you a bit of a look at the capacitor that was in there. So when I removed the switch mechanism from the drill, I found a very unattractive capacitor, half blown. I'll try to zoom in a bit so you can see what I mean, but it's obviously not very happy at all, this little capacitor that sits on top of the switch. It's basically blown apart. So I'll just remove this. Now it's a sort of sliding mechanism, and I have pulled this apart earlier, so it's not quite exactly as I found it, but it's pretty close. But you can see it's just basically destroyed and needing replacement. So what I thought, well, that's the trick. So I'll just order a new one of those, which I was able to find on AliExpress. What I did to try to just double check that was the problem, I just replaced it with an equivalent capacitor temporarily, and you can see that I've just got, probably you can't see the details there, but basically I put in a 0.22 UF capacitor there of the right type. There's an X2 type here, and tried to start the device, and unfortunately that did not work. and what was happening was a very faulty switch contact down here. So it would work partially and then stop, but wouldn't properly work. So once again, looking online, found out this is actually a common failure as well. And so I ended up ordering one of these units as well at the same time. So here we go, got the new switch arrangement. You can see quite obviously very similar mouldings, different colour switch trigger itself actually, but other than that, obviously connection is the same, and well, fingers crossed that it'll work well. It is just a switch, a variable switch, so should be fine. And there's the little capacitor pack that I said was, you could see was blown up. There's the device itself, so it's a bit hard to see, but it's a 0.15 microfarad X1 in this case. So what we've got here is hopefully everything we need to repair the drill. So to just show you the markings on the trigger, there we go, and that's the ratings there, and on the other side there's the indication of what the switch actually is doing there. And I can confirm that's the same as the old one. I'll try and get the old one up in a minute just to confirm, just to show you that. And the little capacitor actually slides on. I'll probably show you in the other camera. I think it's probably a bit difficult here, but a bit fun. You can just see, oops. See the numbers there for connections, and it sort of slides on in basically in that direction there. So the job here is now to replace the old switch with the new switch and new capacitor, and keep our fingers crossed. So to show you how the switch is supposed to work, the new switch here with the more yellow trigger, I'll just get the contact there and squeeze the trigger. You can see it's open circuit there, and as you push the trigger, it's supposed to close that circuit, and depending on how far you push that circuit, you can also close the circuit on this second connection as well. So what's intended to happen is that when you push the switch the first bit, this contact point here is closed, and when you go a bit further, an additional contact here is closed. So both of these are supposed to be closed when connected, when pushed, and only both open when the trigger is not switched. Now if I swap that over to the faulty switch, which is the original one with the slightly orange trigger, I'll put that one of the probes into the same point I had before, and you'll notice without pushing the trigger, I've actually got a closed switch in that position. The secondary position is open, and it closes once the trigger is fully depressed. So that output of the switch is fine. This one is not. And the symptom we had was the motor of the drill basically running without the trigger being pushed. So it ran at all times at a slower speed, ran at all time, and when you push the trigger, it sped up. So it was using basically the two speeds, and obviously not safe for the drill to be running without the trigger pushed. So that's what we're hoping to solve with this switch, and it looks like from the initial tests that should solve our problem. So we've got the switch positioned and the wires tucked away in a safe spot. We'll put the securing block on so that it provides the strain relief so the cable doesn't get pulled out accidentally. I might just do these a bit loosely initially until I do the test, but of course you want these nice and firm when you finish the job. I'll just tweak them up a little bit more. So that's a Torx T15, I believe. Drive. Make sure you're not pinching any cables. Okay, so time to put the back of the handle on. Make sure you don't catch the cables. A little bit fiddly, these things, aren't they? That's that looks like it's going together reasonably well. Just double check on both sides. Yep. The long screw go in the ends. Now these screws actually do have a Torx head on them, not a Phillips head or a flat head, but luckily they've got a bit of a slot in them. So even though I do have a Torx 15 that in theory would work, because they're recessed so much, I can't actually get the screw head in there because of the size of the hole there. So luckily, straight old flat blade screwdriver will come to the rescue. So I'll do this one loosely first, just to position it. Come down to the base where there's two separate shorter screws. Won't do that up fully yet either. Just turn that over, make sure it's all looking good. And I think I can tighten that one up fully now. It looks like it's going together a lot nicely. Back to the last two. A little bit fiddly to get it into the slot once it's in there, but that's alright. There we go. You can see that joint's just closed up there now. All right. So it's time to plug in the drill into the outlet and see how we go. Switched on. Aha. So it didn't run on its own like it used to. Let's see what happens when I pull the trigger. Whoop, pull it slow. It's fine. That seems to be working. think we can call that a successful fix. I'll just take this back off and just retweak those cable tidies just to make sure the table detensioner, make sure that's all working. But other than that, I think I'll call that a fix. So there you go, another fix of quite a good hammer drill, in this case, a Bosch hammer drill that had a faulty switch. And so just to go through what was wrong with this device when I picked it up, it was resetting, or was blowing a fuse every time I plugged it in and pushed the trigger. Found out that the suppression capacitor had actually been damaged, was actually shorting. So once I fixed that, or replaced that, worked out that as soon as I plugged in and turned it on, the motor would run on the drill, would run quite slowly, but would run, push the trigger fully, and it would run at full speed, but it would never turn off when you release the trigger. It would just stay at that slow speed. So looking up on the internet, found out that many people had trouble with that switch, so that two-stage switch there. I managed to find a replacement component for that, and wired that in, and with the new capacitor, new filter capacitor there as well, was able to fix the device, and it's up and running properly by the looks of it. I'll do some proper tests out there, drill a few holes, you know, have a bit of fun, but it looks like it's done. So I'm pretty confident that it's a working drill now. So anyway, I hope that was useful for you, and if so, please hit the like button below. Otherwise, come and join us next time. You might find something a bit more to your interest. So please come back and see us on the Northbourne Repair Cafe YouTube channel.